Today's lesson will be on factorials and permutations. Many counting and probability calculations involve the product of a series of consecutive integers. You can use factorial notation to write such expressions more easily. For any natural number n, the notation n factorial will be n times n minus 1 times n minus 2 times n minus 3 times ... all the way down to 3 times 2 times 1. This expression is read as n factorial. So, example, calculate each factorial. And we can do this, well, we can at least do the first one manually. So, we're going to get 3 times 2 times 1, and 3 times 2 times 1 is just plain old 6. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1, and that's equal to 720. You'll see that factorials get pretty big pretty quickly. So we're not even going to try to figure out what 13 factorial would be. Instead, we're going to look at how we would figure it out using the graphing calculator. So we go to the graphing calculator. You'll want to go to a fresh screen. You can press second quit if you're in some other kind of screen. And you might as well just erase everything that's on the screen just to start with a fresh slate. Once you have a fresh slate, if you want to figure out what 13 factorial is, all you have to do is type the number 13, 1, 3, and then the factorial button. Now, some calculators, like even just scientific ones, do this a little bit better than the graphing calculator. You have to dig a little bit for the factorial button, but it's under math and it's under probability, which is the second option from the right. And we're going to pick either select option 4 or press the number 4, and you get that exclamation point that represents factorial. So once you have 13 factorial on your calculator, you can press enter, and you'll see the answer is 6 trillion. Is that 6 trillion? No, it's 6 billion. 6 billion, 227 million, 20,080. So that's 6 billion, 227 million, 20,080. So 6 million, 227 227, and then it's 020800. 020800. That's 13 factorial. So like I said, factorials get really big really quickly. The next example, we can actually simplify some factorial signs. If we have 9 factorial over 7 factorial, what would that look like? Well, 9 factorial would be 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That is 9 factorial. 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. Now here's the thing. The cool thing about these factorials is we can do some simplifying and not even use the calculator. If you're multiplying a bunch of stuff together on top and on bottom of a fraction, you can cancel things out if you see the same thing on top and the same thing on the bottom, and they're being multiplied by something. And there's no other terms. There's only one term on top and one term on the bottom. So in other words, this 7 crosses out with this 7. This 6 crosses out with this 6. The 5's cross out, the 4's cross out, the 3's cross out, the 2's cross out, and the 1's cross out. And anytime we cross it out, we're dividing a number by itself, so we're replacing all these by 1's, but really that really doesn't matter, because if you multiply something by 1, you just get that number. So we're left with just 9 times 8 on top, and 9 times 8 is 72. So the answer to that, without even needing a calculator, is 72. Okay? Now the next one will require a little bit of simplifying. It's 15 factorial over 10 factorial, 5 factorial. So, if we're going to try and simplify this, we can write this as 15 times 14 times 13 times 12 times 11 times 10. And now here's what I'm going to do. It's a little bit of a trick, but I'm going to stop at 10 and say 10 factorial, understanding that that means 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Why am I stopping there? Well, I'm stopping at 10 factorial because I already have a 10 factorial down here below that it'll cancel out with. And then after that, I have 5 factorial. So that's 5 times 4 times 3 times 2 times 1. And I can use those numbers to cancel out with some of the ones on top. So the 10 factorials will cross each other out. And then we'll try and figure out how we can work out with the top. For example, I've got a 5 down here and a 3. 5 and 3 make 15, so we can cross out the 15, the 5, and the 3. Then what else can we cross out? Well, it's not going to be quite as pretty there because I can take this 4 and cross it out because it goes evenly 3 times into 12. I don't have to cross out the 1 on the bottom, but I do need to cross out the 2. The 2 goes into 14 7 times. So on top, I'm left with 7 times 13 times 3 times 11, which would be 91 times 273 times 3 is 273 times 11 would be would that be 3003 if we multiply 7 times 13 times 3 times 11? 3003? Is it? Good. Whatever. All good. So the answer is 3003. That's what we get when we simplify 15 factorial over 10 factorial, 5 factorial. Next example. There's 4 parts to Achievement Night. Mrs. Johnson and Mr. Knight want to find out how many ways they can arrange Achievement Night. Find the total number of orders possible. We could use factorials here, but we'll first look at this without factorials and then see how we could use factorials. If we think about how we can lead this off, if there's 4 pieces of Achievement Night, the first thing, we have 4 choices. So I'm going to put a 4 here. So we've got one thing there. Then, when we finish that one part and we want to go to the second part, we have 3 choices for that second part. Once we choose that second part and we want to choose the third part, well, guess what? We only have 2 choices for the third part. And last but not least, we have 1 choice for the final part. Once we've chosen the first 3 things, we only have 1 choice left for the final part of Achievement Night. It is 24, but we see 4 times 3 times 2 times 1, which could have also be written as 4 factorial. Either way, whether you write it out like this on top or as 4 factorial, you are going to get 24 ways of arranging the events at Achievement Night in order. Okay? So if you want to arrange things in order, you can do it 24 different ways. Okay? All right. So next up, Mr. Hutton has 10 multiple choice questions to put on the next test. How many ways could the 10 multiple choice questions be arranged? Well, of course, that's just going to be 10 factorial. So we need to figure out what 10 factorial is. And it's going to be 10 math probability option 4. It's going to be 3,628,800. So 3,628,800. That's the number of ways I could arrange 10 multiple choice questions in order. Okay? Now we're going to get into some more technical talk about permutations. Because we've talked so far about factorials, now we're going to talk about permutations. A permutation of n distinct items taken r at a time is an arrangement of r of the n items in a definite order. Such permutations are sometimes called r arrangements of n items. The total number of possible arrangements of r items out of a set of n is denoted as npr, or p bracket n comma r. There are n ways of choosing the first item, n minus 1 ways of choosing the second item, and so on, down to n minus r plus 1 ways of choosing the rth item. Using the fundamental counting principle that we looked at yesterday, npr is equal to n times n minus 1 times n minus 2, all the way down to n minus r plus 1, which is just a symbolic way of representing what we saw above in words. It's often more convenient to write this in terms of factorials. So to do that, we say that npr is equal to n factorial divided by n minus r factorial. Okay, so we have n items, and we're only going to choose a few of them, but we're going to arrange them in a definite order. We're going to talk about 2 things in this unit. We're going to talk about permutations, and that's what we're doing today, and we're also going to talk about combinations. Permutations are always in order. There's a definite order when we talk about permutations. We could be going to watch a concert that Mr. J is putting together with his music students. And there would be a definite order in which the songs are played. So we'd be talking permutations. But if we're looking in a very general sense, we have to ask, does order matter? And if order matters, we're going to be using permutations. If not, we'll be talking combinations, and we'll be looking at that a little bit later in the unit. So, example, how many different ways can the president and vice president of TAD, that's the student council, be chosen from 7 different members? So we'll say that there's a total of 7 members of student council, and we want to choose one to fill the president role and the vice president role. The key thing to keep in mind here is there's a definite order. There's somebody who's president and there's somebody who's vice president. So because of that, what we're looking for is we're looking for 7 pick 2, which is written as we could write it like that if we want. That's 7 factorial over 7 minus 2 factorial. And that would be 7 factorial over 5 factorial. And if we wanted to go about this the long way, we could simplify it like we did above. But we could also use, there's a permutation button right in the calculator. So if we go to the calculator and we go 7, then we go back to math, we go back to probability, and we pick option 2, which is for NPR, and we put a 2 there, then we get 7P2, just like we have on our page, and we press enter, and we see that 7P2 is 42. So there is a permutation function on the graphing calculator. So the answer is 42. So to be quite honest with you guys, if you gave me, if you showed this work on a quiz, you did 7P2 equals, and then you just wrote 42, and you didn't show me any of this work right here, I'd be okay with it. So if you give me just this, I'm fine with it. If you want to do things the long way, because we didn't really even need to use the calculator, you could do it this way too. But it doesn't matter to me. If you take pre-calculus, you probably would be expected to do this question without a calculator, and then you'd have to do it by hand. But this is not pre-calculus. This is applied math. So because it's applied math, we are okay if you use the calculator function. Okay? I have one last example here, but to be very honest with you, this last example is very much kind of like a pre-calculus question. So I think we're going to turf it. Yeah, we are going to turf this question. So that means it's homework time. And if we go down here, homework is on pages 243 to 245 in your textbook, numbers 1 to 18.